We want to find at what t intervals this pair of parametric equations is concave upward, and at what t intervals is it concave downward. So in order to do so, because of concavity, we're going to have to use the second derivative. We've seen this. We saw it on this example that's written on a separate piece of paper for me. And so let's jump in. First of all, because we have the luxury of doing so, we're not timed in this, like a free response question, we could get a context for it. So let's go to mode, and let's type parametric. If you want to follow along or you just want to watch, that's fine too. We're going to see what this looks like. So y equals after we do that, and we'll type t squared plus t here, and then 2t minus 1 on that one, and we're going to graph it. I like to go to a standard window first, so zoom standard, which is 6, and I'm seeing some concave down here, which means I'm not seeing concave up based on what I see. So usually, actually always, on these calculators with this operating system, when you go to a standard window, the window begins with a t-value at 0, and I would like to go, I guess, backwards in time. Don't have a time machine, but we'll try it. So negative 2 pi is going to be where I start on this. And then you'll see, there we go. There's some concave up, there's some concave down. So extending into the negatives gives us a different context for this. So let's move forward. In order to find the derivative, well, in order to find the second derivative, we need the first derivative. So let's find the first derivative first, which will be pretty easy. dy over dx, so the derivative of the y stuff over the derivative of the x stuff, the x function. And then as we take the second derivative of that, again, it's not as straightforward as you might think, like, oh, let's just take the derivative of that. Yeah, let's do that, but then we're going to divide it by dx. And again, here's the y. It may not be the y, but here's the formula. So take the derivative with respect to time of what you just found and divide it by the derivative of x. So here we go. We are going to take the derivative of that with respect to time. I'm going to write a little bit too much here. So we're going to take the derivative with respect to time of that. Now, if you're looking ahead, you're thinking, man, that's quotient rule. And I hear you. You're right. I'm going to treat it like a chain rule instead, though. Oops. Only I'm going to write the right thing and not the wrong thing. Or I'll just white it out if I do it wrong. 2t plus 1 and then negative 1. Okay, I'm going to turn it into a chain. It'll be easier if we do, trust me. And then we will put that here. There's that. So we're going to take the derivative of that and then divide it by the derivative of x with respect to time, which we already found to be 2t plus 1. So 2t plus 1. Now if you're looking like I could cancel, don't play that game yet. Let's take a derivative first. So denominator, no big deal. Numerator, chain rule, so negative 2, 2t plus 1, and then times 2. So what I really have, whoops, that's to the negative 2 power. I'll subtract 1 from negative 1. And that's going to give me negative 4 here. And then all this stuff, this 2t plus 1 to the negative 2, moves down to the denominator and becomes 2t plus 1 squared times 2t plus 1 to the first, which is 2t plus 1 to the third. Okay, now let's answer the question. We found the second derivative. On what t intervals is this concave upward? All right, if this is going to be concave up, then this will be positive. So negative 4 over 2t plus 1 to the third will be positive. Okay, think logically with me. What will make this be positive? A fraction that has the same sign in the numerator and denominator will be positive. My numerator is locked in at negative 4. My denominator needs to be negative also in order for this to be true. Therefore, 2t plus 1 to the third power should be negative. Now, if you're like, how did I go from here to here? I didn't use any solving. I just used logic. So we can just basically go from here to here by saying I need this whole fraction to be positive, so the denominator had better be negative. Let's keep solving. If 2t plus 1 is less than 0, oh, by the way, because we're raising it to the third, negative input to the third, still negative, you know, you get it. Anyway, cube root of 0, 0. 2 is going to give me, or t is going to equal, that's what I should say, t is going to be less than, let me get it right this time, negative 1/2. If we solve this. So the answer to the question is this graph is concave up for t values that are less than negative 1/2. Okay, you can see where this is going, so we'll move through this part very quickly. Concave down, and that's going to happen here. That's going to happen here. Well, what makes this negative? Well, it's going to be negative if the numerator is negative because it's stuck being negative, and the denominator is positive. So you just saw this in a slightly different context. There we go. We'll just jump straight down to the answer. So t is going to be greater than negative 1/2. So we're going to have concave down for t values that are greater than negative 1/2.